My name is Jean Tere, and today I will be talking about the impact of entropy and the mutual information based feature selection on classification model performance. And that's my topic of my research and numerical experiment. And introduction in ML. Feature selection is a process is very crucial for a good model, and we have two various methods to help this process during this numerical experiment. And we will discuss these two and its entropy and the mutual information. One is unsupervised method, which measures uncertainty, and the second is supervised method that evaluates how feature is related to the target. And data set and preprocessing, I had a data set which is called airline passenger satisfaction, which consists of 24 features. They have various of types of features, for example, numerical, categorical, ordinal, and etc. And I applied encoding and scaling for preprocessing, and our dataset is balanced, and the label is distributed 55% false and 45% true. And feature selection and models. For feature selection, it was done by entropy, mutual information filtering, where we took 60% of all features. Classification was done by a logistic regression, decision tree, random forest, and the support vector machine. And the metrics used were accuracy, F1 score, recall, and training time. And as you can see here, I created another data frame where I calculated for, mutual information and entropy for each and every feature that we had, 24 features. And here we can see already the results where I used the all features dataset and the entropy-based features dataset and the mutual information-based dataset. And as you can see, for the logistic regression, it had a very good scores for all features, but nevertheless, it was not that bad for entropy and for the entropy and mutual information, despite the fact that they were cut 60% of features. They were only 60% of features, and it shows how it was a good decision to filter it by entropy or mutual information. But of course, mutual information is more because of its supervisedness. It's more accurately chose the features which are related to the label, and it's not that far away from all features results, as you can see here, for accuracy, F1 score, and recall. And here we can see that it very much decreased the time of training time of the model for both entropy and mutual information, because it had less features than the original dataset, and it's like 4 times less than it is with all features. And next is the decision tree. For the decision tree results, we can see that it's very high for every one of them, like at least 90% of accuracy, F1 score, and recall, and it's pretty cool results. Taking into account that it's 60% of data, and entropy is doing a pretty good job also here, and training time also decreased for entropy and mutual information, but for mutual information it's more or less than for entropy. And here we can see the results for random forests, and the random forest did a pretty good job also. It did better than logistic regression and the decision tree, and it had 96% of accuracy, 95%, 94% of recall and F1 score for all features, but we can see that it's only like 1-2% away from entropy based feature selection, and the mutual information based feature selection is like very close to all features selected data set, and the training time also decreased, and we can see that the model did a good job on a filtered data set also, and it proves our kind of proves our point that mutual information based and the entropy based features are good for model training, even though they are less by 1-2%. And the next model that I added from the last SIS, it was a new improvement. It's a support vector classifier results, a support vector classifier model that I added to check if it will have the same results. And as we can see here, it's pretty the same thing happening here, but the results are kind of the same, but of course it's less than the all futures, and it should be backed up by training time. But as we can see, the entropy based future selection did a much more job than the all future selection, all future dataset, and it was unexpected by me, and I am still investigating why it happened, but most probably it's because of the it's because of the nature of support vector classifier, and but overall it did a pretty good job with the mutual information. So for the conclusion, we can conclude that future selection matters, and it speeds up training and improves clarity. Entropy is useful but unsupervised. Mutual information solves the unsupervisedness problem of entropy filtering approach and gives a good relatively good results. And that's it for SIS5, and for final work, for the final presentation. I'm going to add more metrics and listen for your suggestions and improve my numerical experiment in a way that you see it will be better. And so that's it. Thank you for your attention. See you.